We now have code that will allow us to load the results of our analysis from the incremental folder. Let's look at ways to plot these results. We've played around with plot a little bit, and remember that we need to plot the times of the experiment versus the concentrations of the reactant through the experiment. In this case, they're now in this results list. So if I put in results $, if I want to get to the vector of times, then I need to put in the times. Or if I want to get at the concentrations, I put in CONCS or conses. And that gets me to those vectors that I want to plot. And that means, as we did before, I can use the plot function and say on the x-axis, I want to put in the results $times. And on the y-axis, I would like to put in the results $conses. And this gives us what we saw before. And we are using the default graphics device. And when you're using RStudio, the default graphics device automatically sends plots to this plots tab in that what by default is in the lower right-hand window of the development environment. Now R is making a lot of assumptions about what we want to see in this plot in order to create it. It's decided that it's going to create the axes in a particular location, and it's decided how to scale those axes in a particular way, and it's decided what to put on the labels for the axes by default. These are none of these things we have told it yet. These are all assumptions that R had to make. Well, that's something that we can take over when making plots. So I'd like to spend a little time diving a little deeper into what the plot command does and what you can call on your own to create plots that will give you a little bit more control over what they look like. First of all, most of the graphics tools in R all end up using the same graphics rendering engine. And the first thing you need to decide is which interface to that engine you want to use, where the interface you select will depend on what kind of graphics file or graphics output you want to generate. So right now, by default, we're using a device that will generate a graphic output directly into RStudio's plots window. But we have a choice here. There are lots of different graphics engines that we could use. There are graphics engines like JPEG, JPEG, that is going to create a JPEG file. There are PNG files that you could create in terms of a graphics interface file. Those are both raster type files. You can also create vector type images, which are pretty commonly shown in a PDF file. So one of the graphics engines that I like to use is the Cairo PDF engine. Cairo PDF graphics device. And to open up a new device, there's a function that's called Cairo PDF. And this particular graphics device is specifically going to generate a PDF file when it generates the graphic. So if I do a help on Cairo PDF, one of the required arguments it's going to need is a file name. I'm going to have to tell it what the file name is. And also I'm going to need to tell it the size of the canvas. So I've got file name here for Cairo PDF and width and height. That's the size of the canvas, and in this case, by default, the unit is going to be in inches. So if I want to tell it a file name, again, I'm going to tell it a path to a file here, and I want to use relative paths to make sure that this code will always work, even if the data product moves around on the computer. I'm going to put a ... because I want to go from the protocol directory to the parent of the protocol directory. I can hit tab to tell me what's in that folder. In this case, the graphics that I'm going to create, I'm going to consider that part of the product. It's really common to provide some sort of visualization of the data alongside a product that you've generated. So instead of the incremental folder, I'm going to put this file in the product folder. And I'm going to call it visualization.pdf because that is what we're generating here, a visualization of the analysis. And then I'm going to give it the undo that. I'm going to give it the .pdf extension because a Cairo PDF device is going to create a PDF file. And it's pretty helpful for my operating system to know that that's a PDF file based on the extension of the file name. So that opens up a device. And in the case of PDF or really any of the devices that write a file, they're not actually going to write a file until you close the device. So how you close a device in base R is to do a dev off, call the function dev off. And that says for the current device, the current graphics device, turn it off. That's simply what that means. So nothing is going to be written until I turn off the device. Now, in order to create a plot, you use the same graphics functions no matter which device that you're using. So just like before I was using plot to create a plot, I can do the same thing here. And I'll do a plot, and I'll do an x equals results $ times y equals results $ conses. Now, if I run this code, I have changed the device. I've created a new device called Cairo PDF, and that's the device it will use until I turn that device back off again, which I'm doing right here. So if I run this code, it's no longer going to create a plot in this bottom right-hand window. There's a plot here, but that was here from before. I'll erase that. And I'll run it again just to convince you that the plot doesn't end up here when I call plot after this device is opened. However, if I look in my pipeline, in my product directory, I should have a file called visualization.pdf. And I'm going to open up with my default PDF reader, which in this case is the Sumatra PDF reader. I can see the plot has been created. Now, something that I forgot to do here is create the size of my canvas. So I'm going to close this. If we go back to the help window here, recall that by default, the width and the height are set to 7. So this is going to be a square aspect ratio. And I forgot to change that when I created my device up here. So my code's getting wide, so I'm going to make it narrow here and put 1 argument per line. I'm going to say the width argument here, I'm going to make 8, and the height argument, I'm going to make 6. So if I rerun this, and I go back to my pipeline, look at this visualization, now you can see I've changed the aspect ratio. It's now wider than it is tall, and that's a 6-inch tall by 8-inch wide aspect ratio of my figure, which at least to my eye is a little bit more pleasing, something I'm a little more used to looking at. So those are the basics, but ultimately we want to break down what plot is doing because we want to have a little bit more control over what this graph looks like. So that's the next step.